Okay, so thank you for your patience, especially Miroslav's patience. So we're going to start the last lecture of today's session, which is going to be about spotting the web vulnerability. Miroslav Stampar is the developer of the widely used open source tool SQL Map that is dedicated to automatic detection and exploitation of SQL injection flaws. He's constantly developing and improving it since December 2009. And today he will be showing us the code that's behind the vulnerability, sampling attack scenarios and ways how to repair and protect them. And thanks again for the patience, and the floor is yours.
Hello, everybody. As you heard, I'm Miroslav Stampar. I'm one of the developers of SQL Map project. You probably heard of it. Today, I'm going to speak not about SQL Map. Some of you will probably be disappointed. Also, here you won't learn any new hacking techniques or stuff like that. Today, you're going to see what's behind code reviews done by many exploit writers or professional security researchers. So today, if you are a defender, you should see what you shouldn't do if you are an attacker, and if you have a source code of the attacked web application, you should see what you should look for if you are looking for the vulnerability inside that code. So this is a short talk overview. It will consist of 3 parts. First part will be introduction to commonly exploited web application vulnerabilities. I want to note here at first that only those web vulnerabilities which count, so which are highly valued, will be covered here because we have a short time period. There will be 5 or 6 groups. You will see afterwards, after the introduction, there will be a core of this talk. There will be lots of examples, what to look for in real-life examples which are public, and how those web applications became vulnerable at the first place. At the end, there will be some mitigation tips and tricks. So this is a must. If you are talking at the security conference, you shouldn't just say people what's the problem. You should also pinpoint what should be done with those problems. Also, one more note is that there will be lots of PHP going on here. It won't be boring or too complex, but some basic stuff will be noted. So also non-technical people should understand what's going on. For starter, just to have the clear vision for myself. How many of you have coded at least one line of PHP code? Okay, majority. That's easier for me. At security conferences, you need to have some hard data. People don't like, myself especially, when people talk about some abstract stuff without any background. So I made some statistics for this team, for this conference. I've collected vulnerability names which could be found at the ExploitDB site. There were more than 10,000 of public web vulnerabilities there. I made some Python script, collected all those names, and I've collected all bigrams. Bigram is a two-word formation. So I ran this script, it collected all names, and resulted with this. You can see that the SQL injection is the far most prevalent vulnerability exploited by people around. Also, you have those injection vulnerability BGRAM, which is also including some of those SQL injection and cross-site scripting stuff. You see some inclusion, some local file inclusion. You see also more SQL, remote vulnerabilities and stuff like that. This is just for you to see what's going on in the vulnerability world. What is hot, what's not hot, and stuff like that. This is only top 20 BGRAMs, so there are lots and lots of other stuff going on. You should just have the clear vision that this is the far most exploited stuff going on. These are the top 10 web application vulnerabilities found on ExploitDB by the visits of the attackers themselves. So here you can see that WordPress is highly targeted platform. Also, we buy it in forum. There are also some YAML stuff and blah, blah. Platform, far more prevalent is PHP. One interesting thing that could be seen here is that 2011 was highly active year in finding web vulnerabilities. You know that probably if you are reading security newsletters and stuff like that. Last year was the worst if you are a defender. So lots of sites were attacked, exploited, and stuff like that. Just one thing. This is my favorite, Team Thumb. This is maybe a false number here. This is only exploit for the Team Thumb plugin in the WordPress. And thing is that Team Thumb was indirectly used in lots and lots and lots of other WordPress themes and plugins. So this is not a clear number. Lots of sites still are vulnerable by this exploit around. And this number, if you sum all of those indirect vulnerabilities, should go right here. This is the first part, as I stated in the talk overview, some introduction to the vulnerability classes. SQL injection, you all probably know what is it. The core of the SQL injection is usage of unfiltered parameters and concatenation of the same inside the queries provided to the database. So you basically have a query and you put blindly or dumbly, you put a get or post or some other request parameter inside of it and you run it against the database. Various techniques are used. If you run SQL map, you should know that there are 5 or 6 standard ones. Also, goal is unauthorized access to the underlying database. So attacker just wants some data which could provide him an easier access to the upper levels of the affected web server. And this is an interesting statistic which could be found in 7 Safes report for 2010, that 60% of all breaches that year were including SQL injection. This is a hello world of the SQL injection. So you basically use in this example, get parameter ID and you blindly just concatenate it to the static part of the SQL query. Sample attack goes like this. This is a union attack where you try to concatenate or append the values of the new query to the original query, to the original result. So if the original result was for ID equals 1, some stuff from form logs, you just append with union all select in this form all users and password from MySQL user table. Cross-site scripting, in short, you are trying to inject a browser executable script into the existing page, and trying to lure the end user to run that same page with the injected cross-site script. There are two forms, persistent and non-persistent. You probably heard about reflected and stored by other names. Those non-persistent variants are today not as much valued as persistent ones, because in this form you have to lure one user to use one link you provide to him, but in this form you have a stored cross-site script attack inside one page which is accessed by many users. This form of persistence, this is one example of persistent cross-site scripting attack was this famous SEMI cross-site scripting worm, which infected over 1 million MySpace profiles in under 1 day. Also, these are possible attacks. These are not all, but highly valued attacks, especially this cookie theft. Hello world of cross-site scripting goes like this. Basically, you have a get parameter, which is unfiltered, and you just put it here into the output of the web page. Sample attack could go like this. So you, instead putting your valid name, you can put inside the get parameter something like this. This is a JavaScript code which changes the link that is referenced by this part of code. Instead of www.site.com to your domain. So when user enters this page, he will instead, when he clicks that link, he will go instead of the www.site.com page, he will be forwarded to the attacker.com page. File inclusion. In short, you probably all heard about the web shells, and this is it. So basically, web shell is something highly valued by attackers, especially remote ones. Difference between local file inclusion and file inclusion is that in remote file inclusion, you are storing in this example, PHP executable or PHP script at the remote location you control, and you try to include it inside the already vulnerable page. In local file inclusion variant, you need to somehow try to find a way how to upload that same web shell into the affected web server and try to run it with the affected web application. Hello world for it goes like this. Basically, here you can see that if the request parameter page is set, in this sample, web developer blindly used that request page for inclusion of that same page, which is referenced by that request parameter value. So for those of you who haven't coded in PHP, you will need to know just few things to follow up in further section. There are few super global dictionaries inside PHP, which are important in this talk. It's one of those is called request, one is called get, one is called post, and one is called cookies. Inside of all of those, there are parameters which are handled by the end user toward the server. So in this case, this request has the get and post parameter values, which is handled by the end user toward the web server. One example how to attack this vulnerable code goes like this. Basically, you can see that page parameter value will get this value, and this piece of code will just say if request parameter value is set, use that parameter request value for inclusion inside this piece of code. And this is just for the this used highly in those kind of attacks, because there are lots of cases where you need just to override this value, and you can just put here a dummy value. In this case also just this part without PHP could work. So you will get an inclusion from the remote site you control, having the shell PHP containing a malicious content. File disclosure, this is highly related to the file inclusion part, but in file inclusion part, you are trying to inject the PHP code or ISP code inside the vulnerable page. In file disclosure, you are trying to disclose the content of the file, which couldn't be, which normally is not exposable by the web browser. Directory traversal is just one variant. It just happened this formation. We are just going down to the parent directories, and you are trying to go to the lowest level possible and try to inject some, try to reference some interesting file. Easiest for exploitation, done by lots of web vulnerability tools. Example vulnerable code goes like this. You can see here, this is just this looks like the same example like in the file inclusion. That's why I've told that this is pretty much similar to the file inclusion vulnerability, but in this case, you can see that you can't eject anything that has HTTP inside, so you can get remote file inclusion. But if you're able to upload the web shell to the affected web server, this will become a file inclusion vulnerability. But let's say, just for the argument that you can't do that you can just use something like this to disclose the file content of the web server. In lots of examples, instead of include, you will see also in later, you will see that instead of include, there are lots of read files here. So read file is not able to execute anything, it just reads the content of the file. So if the web server is affected by this, it will try to read and provide the content of the file of interest. Remote code execution, it provides a way to execute arbitrary code. Difference between this one and file inclusion is that in this case you are trying to include, you are either trying to include the live code. This is rare. So if the vulnerable code uses eval, to evaluate code, you will try to to inject the live PHP code inside, or in other variant, in what other variant you will manage to use the vulnerability itself to write something to the back end and to execute that same file. This is the example to clear this stuff. In this example, you can see that the file preferences time zone PHP is opened and written the request parameter TZ and ended with the proper PHP ending, and at the end is closed. So you can see that this is somehow different than the file inclusion, because here you are actually writing something down to the request parameters that is written at the backend and later on executed. So sample attack could be something like this. You are calling the vulnerable application. You are telling it that the time zone is US. This is just a dummy value, and you are just putting the splitting line here for shell exec for some of malicious PHP code that will be written to the time zone PHP file. Later on, in second step, you are trying to access that same PHP code, and you're just appending here malicious content which will be executed by it. And now, this should be our core of the presentation, live examples of each of those groups. So you could see from those what are common mistakes and what are some more obscure cases where developers of the web applications have missed something either in the writing of the code or in the part of they try to make it safer, but they just blew it away. So here, in this first example, in each of those examples, you will see the name of the affected application and its reference in exploit.db if it's available in CV or open source VDB. In this first example, it's OpenConf web application. When you are spotting the SQL injection stuff, you should always try to find the meat, the core of the application. Try to find some select, update, insert, delete stuff inside the code. In this example, this is the meat. Here you can see that application developer used some kind of function to make safe to filter the content of the provided parameter values. But the problem is that this sample filtered single quotes and double quotes in the provided values. But in this example, here you can see that to escape this context, you don't have to need neither single quote nor double quote. You can just put inside the post parameter value PID, you can just put some integer value and just continue on with one of those SQL injection techniques, either union or select or stuff like that. So in this example, it's important to pinpoint that you will see some examples where web developers have tried to make the application safer but failed. In this example, if the developer could just put the single quote here and at the end, then escaping of that same context would be impossible, because to escape that single quote into the SQL realm, you will have to put another single quote, which would be filtered by this save SQL str function. Another example, you can see a query here. And now you can see that there are single quotes here. So for escaping this realm, you have to put a single quote. But in this example, the application developer didn't use any form of filtering of those values. So just putting the language cookie to some single quote union all could just provoke the SQL injection in this part. Third example for SQL injection, you can see here SQL injection insert statement. Here you can see one of affected parameter values. So you can see here that the post parameter value, predict ID, was compared somehow to the iterated values. It's not important for the sake of discussion what it does, but this integer value comparison just told you that you shouldn't use this value for the SQL injection, but there is one other post parameter which is not used by any means, nor filtered nor compared previously. It is just a second. Not the predict ID net, but the predict selection. You can see that the predict selection is taken from the post request parameter values, put it inside the local variable select option, and just unfilteredly used here selection options. So to exploit this vulnerability, you just have to put some dummy value to the predict ID post parameter value, and use some enclosure of this insert inside of this option, and put some, I don't know if it's a mix of SQL Server or Postgres. They have that stack queries. You could just continue on with another SQL statement. Or in advanced cases, there are time-based attacks against insert statements. So you could put inside of it some case, if it's true, to put a time delay. If it's false, to just do a normal refresh. This is one of those tricky examples where it's not quite possible why is this vulnerable. The writer of this web application used some form of protection, HTML special characters, filtered those special characters, also those single quotes, double quotes, and stuff like that. At least it seemed to the web application developer. So you can see here, to break into the SQL realm here, you have to put a single quote here and to put something inside the start here, which is in this case get parameter value. Problem with this is that HTML special charts by default don't filter single quotes, and the web application developer didn't know that. So he at least thought that he was protecting himself by using that special filtering, but he didn't read the documentation for it, where it says that where there is a another parameter and quotes which need to be added to the call of HTML special chars to also filter those possible single quotes here. This is one of also obscure cases. This was fine by me. It was, at the first look, it appeared to be like unexploitable. So the web application developer used some base 64 encoding of the get parameter value track. It used some dashes to split add group and block values inside the get parameter value track. And afterwards it used those, just one part of that meta here. And the problem here is that now when you look at that piece of code, you'll maybe spot this part, which is quite important. So to the naked eye, this would be quite obscure, but if you get what's this saying, you would probably stuck at this prepare part. But prepare part is using those prepare sequence statements. Probably some of you have heard, which are quite promising way how to prevent sequence injections. And the thing is that the author himself used the prepare in this example the wrong way. He made the sequence statement by concatenating those unfiltered values here. But to properly use prepare statement, you have to make one part which is sequence statement and the other part with the parameter values. So he blindly thought that this will protect him. Also, probably with this one, this is some security through obscurity. At least it seems like that. But when you break this part, you will come to this part where he just used the prepare the wrong way. So proper way should be here to make the select link from, instead of using that, this variable not affected by us, but this add is coming from the track. Thing is that instead of concatenating that adds parameter value into the statement, he will just need to make the mark that this should go the add parameter value that VPDB prepare has. That's I believe it's something like, I don't know, like percentage sign add, and afterwards he will just need to make a comma and the value of the add. So just remember that if you use prepare statements, just remember that you have to split the sequence statement part and the parameter value part, and this will not protect you if you are using just the sequence statement part. In this example, this is a sample where EH request with header was used. So probably some of you can recognize that this is some kind of Ajax script. Finding vulnerabilities against Ajax scripts are far popular today because lots of Ajax scripts are tiny and written in I don't know 20 minutes without any proper security considerations. This is one of those examples where you can see just a second to see what to see. You can see that here application developer correctly casted something that should be an integer value. So we can't put anything here that is SQL injection related. It will just cast it to the integer and put it here. And that's the proper way. But the problem is with this one. Problem is that post parameter value item is blindly used for extracting those values inside of it, and used, you can see this value, used here inside the update statement. So as printf, there are some talks around what should be used for preventing SQL injection. As printf is not the solution. It just enters blindly the content of this value, which is coming unfiltered from this, and it's just coming here. Okay, now some examples for the cross-site scripting. HTML template is a popular PHP application for templating PHP pages. Here you can see that for filling the template, in this example for the upcoming link parameter value, get value of for ID was blindly inserted here. So anything maliciously put inside the get ID parameter value should become a part of the proper template field page. So this is only for displaying that content of the field template. So you should, maybe the most important stuff that you should remember from this presentation is never to use this. So if you see this and you are a web developer, you are in trouble, and if you are an attacker and you see this, you are in a bit of luck. This one example for the popular WordPress platform. So not for plugins, but the WordPress platform itself. Thing is that there was a piece of code for displaying comments coming from users on the platform itself. It stored the outer URLs inside the database in an unfiltered form, which is okay, because lots of web developers, they don't want filtered stuff inside the database stored, because if you tend to over-filter stuff, then you will end up with the losing stuff. So the common way how to deal with vulnerabilities is to store stuff unfiltered into the database, but when you present it or use it inside the page, you should somehow filter it. In this example, author URL was just blindly get from the underlying database and displayed inside the page content. This is one of examples for the Shotbox alike application, where post parameter values nick, email, and shout were put inside some storage file, and later on they were displayed in the display part. And now there are several interesting parts here. So this is the most interesting stuff. You can see that there is a variable allow HTML here. By default, it was set to the false. So web application developer said, okay, if the end user doesn't want to allow the HTML, I will just strip any malicious content which could prevent the cross-site scripting, or if he does want to allow, it will display the unfiltered content. And the problem, especially at the at the time when the shoutbox or that exploit was found was that the strip tags were vulnerable to one form of attack, where instead of, so what does strip tags do? It just removes all possible tags from the content to prevent any script injection or stuff like that. But the problem was in strip tags in that time, 2004, that if you have put the script tag here inside the content of that post parameter values containing a /0, strip tags would just fail and just allow it unfiltered to the end user. So in this case, the application developer thought that the HTML will be protected by it, but the end attacker could use that vulnerability to bypass that security. File inclusion. In this example for Zen card, here you can see that the cat parameter value type filter was put here into the type filter variable. Concatenated to it was the filter PHP. This was one local function which was too large to put inside, but it just normalized value of the provided path. This was one constant and blah blah blah. Thing is that you could in this attack you can just easily put // and go into any display any kind of or not display. You can include any kind of PHP if you have managed to put the PHP to the web server affected. Thing is that this is not prone to the remote file inclusion because you can see here that something is prependent to it. So you have to find a way how to upload some shell to the web server and pinpoint through the type filter to the location of that script. This is also a similar example where you can see that the post parameter value lang was blindly put here, so without any checking or stuff. You don't have to read this. It looks query, but it just sees if the name of this same script is config PHP. Afterwards, that same conf lang is used here. So if not file exists, it will include some default value, but if file exists, it will include itself. Also, this is an example of local file inclusion. If you are able to include the web shell to the affected web server, and just go to the parent directory, and put the name of the shell, and then it with the int PHP. This could be also a hello world for the remote file inclusion. You can see here that get parameter value abs path is blindly included into the source of this code. So you can just put the web shell to your server and just put the path toward it into the apps path. Only thing is that you have to either name it vpload.php, or you can use that trick that I've stated at the beginning, where you put the dummy get value full bar equals this. File disclosure. This is the popular function found in those kinds of vulnerabilities, where file is blindly, unfilteredly, unchecked by cache developer included or not included for the execution, but just for the representation of its content to the effective application. So in this example, you can put into the request file name. You can put dot dot slash dot dot slash dot dot slash etc slash paswad for password files or .htaccess or stuff like that. In this example, there is also a read file, as said, popular in these vulnerabilities. That file you can see here. Just to see what to see. Request parameter value, which could be get or post, call image name, is just appended to the some predefined directory name. And that same file is read here and displayed as the result of that same web page request. Remote code execution. This is a popular function called in those vulnerabilities, where something is written to the underlying PHP file, and you are in control of that same stuff that is written. In this example, you can see that post value form single user login is put into this some kind of dictionary, settings, single user login, and afterwards, that same dictionary is iterated in this form. Every single key value is iterated from it. One of those is also single user login, and is written into the underlying PHP file. In this example, that includes settings PHP. So every single item from that settings file is written. One of those is this, and you can just put here some malicious PHP code which will be written to this file, and afterwards you can just access with the web browser this same location, and you'll have, if you have put here a web shell code, you will have a web shell here. In this example, you can see that this looks at first like obscure piece of code, but this piece here says, I will start to log what is going on here, and at the end, I will write that down, what is output buffer written. And display array for this will basically go through all post parameter values, try to display it to the buffer, and here those values will be used as a parameter value for write info. Inside write info, those same data will be written blindly to the FP. In this case, some predefined file, some predefined directory containing data.php. And at the end, some of remedies for all those stuff. So if you are a defender, you should at least remember some of those things. First one is data validation. So you should discard all that data which doesn't look proper to you. In this case, parameter value phone, which is probably used here from, I don't know, get post request. It's matched by the regular expression put here. If it doesn't match, it just that same page dies. So it just say your phone number is invalid, and it just closes the further output. Also, there is one thing that should be noted here. I've noticed it. So I have noticed a problem in my code. So this can be exploited. So I'll need to update it. Thing is that this is a popular way there is a popular way how to exploit those regular expressions. And thing is that I haven't stated that there needs to be a start here for the string comparison and end. So thing is that you can put inside the phone value something that is malicious and that can end with the proper telephone value. And this regular expression will tell me that's okay, but it's not but obviously it's not okay. So you have to remember, if you are using regular expressions for data validation, you have to take care to put the signs for there is a sign for start here and sign for the end of the regular expression to match this same expression from start to end, and not at any part of the value. So there is data validation, there is data sanitization. If you expect something to be integer, cast it as an integer. If you expect something to not have HTML content or malicious content, use the strip tags. Strip tags was affected 7-8 years ago. Now it's quite okay to use it. Also, this is an example where you just replace all non-alphanumeric values with blank stuff. Here you can see a proper usage of sprintf, where MySQL real escape string is used to filter out all those possible quote signs which could escape this realm of those single quotes here. Output escaping. This is a must for preventing cross-site scripting attacks. HTML special chars is a popular function here. Here you can see that end quotes part, which was forgotten by that same web developer previously, one of those examples. So there is no way to put scripts with some malicious content inside, because those script tags will just be, in this case, they will be just properly filtered. And one of those remedies, especially for SQL injection, is to usage of prepared statements. This is a proper way how to use it. This usage of PDO PHP library. Here you can see that the ID parameter value is pinpointed here by some special means, and afterwards it is binded with that request parameter value. So this is replaced in this part with the most safer way. That parameter value is replaced by this. So this can, by any means, contain the SQL injection inside, because that same prepared statements make sure that there is one part which is statement and the other part which are variables.